Thank you, MX Media, SSMB, for inviting myself for the seminar. So, when I see the participants, it is like Steel Day becoming like an IPL. So, when we have a session of 2 to 3, so now it is 2:45, so the openers had the time and the finishers has to rush it up. So, happy about that. Also, there's another point where the parallel track, I think construction has attracting more people than when compared to design. So, as contractors, as construction companies, they take more leverage on design nowadays. That's what I feel, despite being a construction person. So, I am continuing from what Sarhav went off. So, this is also a project where Optimal has been there as a peer reviewer, and TT is the contractor's designer. And as EVERSENDAI, it is a design and build project for us. So I'm going to take you through quickly on this DLF Taramani. I have been asked purposefully by Avneet to take care of the design parameters, but I will quickly run through and I will discuss more on what is that peculiar in this particular project. So in this particular presentation, I am going to review on the structural systems and few calculations which I am going to skip for sure, since I don't want anyone to get bored. Okay, and we will discuss more on the beautiful features of this particular project. So I'll get you through the basics of this particular building. So this is a out of the total 27 acres of this land, which is by DLF. So this is the phase 1, which is the 2 towers of 20 floors each. It is a design and build, and 1,100 tons is the approximate structural steel volume in it. And it is 18 months is the project duration, and EVERSENDAI construction has been given with the design and build responsibility. Architect is RSP, and the proof consultant for the client, it is Optimal. So it is a 27-acre campus, and it is located exactly in the IT corridor of Chennai. So if you take the levels, we have basements, 4 stills, and there is a podium. Then typical floors, and in between we have 4 refuge floors, terrace, multi-terrace, and machine rooms we have. So floor to floor height is 4.2 meters, and the column span is about 10.8 meters. So it is totally around 10,000 square meter each floor. So this is the site plan. You can see the complete structure, the complete area, it is vacant, and the block A and B, it is the only area which is going to get constructed, since it is a phase 1. It has been developed in 3 phases. Can I have the video? Yes, in terms of logistics, we have, as I told you, this is a very huge area. So we have enough area in terms of all the logistics, and there are about 8 cranes has been placed for the construction. So these are the typical floor-to-floor heights. It's totally around 85 meters as a structure overall. So as a floor system, it is a composite floors. So all the columns are encased columns. There is a steel structure, steel column which is going inside, and we have concrete encased. The concrete, the encasement is having minimum rebars inside it. And the foundation, it is majorly all are pile foundations, and this is a very clay soil. And the shear walls are of RC core walls, and it has thicknesses varying from 600 to 250. I will show you the details of that bit later. So the composite columns were varying from M40 to M60. Core walls also similar concrete grade. Piles and pile caps are of M30 and M35. Anchor bolts, the anchor bolts, whatever we have used, there are few with 4.6 and majorly with 8.8. So in terms of composite slab, as we know that everywhere we have to now stick on to 90 mm of concrete as a thickness where we require for the 2 hour fire rating. So based on that, nowadays the usage of 80 mm trough has been gone off, especially except a few projects 80 mm trough is not getting used. So majorly we are getting into 60 mm trough. So this is 60 ECA 60 where we produce our own deck. So here we have used 1 mm thick sheets. So I'll just quickly run through the loads. It is a normal IT building, so commercial loads as per IS 875 has been followed. So the wind loads, it is 50 meter per second, and for seismic, it is zone 3. I will just pass on. Yes, on fire, so as per NBC, it is been taken as Group E, which is the business class, and if you take the next class, subdivision, it is E3, Electronic Data Processing Center, E3. Then in E3, we have Fire Zone 2. So for Fire Zone 2, the requirement is type 1 construction. So for type 1 construction, the requirement is for the columns, it is 4 hours, and for the beams, 3 hours, and slab 2 hours. So here we have done a comparison report where between NBC, BS, what are the different parameters required for the same fire rating between the different codes. So as I told, for the columns it is 4 hours, and for the beams we have gone with vermiculate, which is about 20 to 25 mm thick vermiculate thickness was there. And the slab is of 2 hour fire rating. So I'll quickly run through this. I'm not going to take you. If you want anything in detail on design, yes, I am ready to explain about this. So in pass of time, I'll just pass on to this. Wind load calculation have been in detail made, and seismic calculations based on the zone factors, importance factors, complying to the latest parameters, it has been made. And the time period has been calculated initially manually. We have calculated, and the time period as per the record is 0.58. And this is the core wall. The core wall taking care of all the lateral loads. There is a various between 500 and 200 mm thick. So this is done through E-tabs on the various design parameters. So as we normally stick on to the practice, and it is a very regular building, and for EVERSENDAI doing regular building, it is the best much simpler. So the first mode is Y translation, and the second mode is torsional, and the third mode is X translation. So then Bayesian normalization happened with the scale factor, then the normalization made. So the final achieved is around 0.4 seconds. The load combinations for strength and seismic, it is we have done as we have been there as a design build contractor. We have gone through different codes, and in discussion with TT and Optimal, the load combinations has been frozen. And various load combinations have been taken for different types. For foundations different, for composites members it is different. And the different modifiers, stiffness modifiers have been taken up. So the next one is the requirement of P delta analysis. P delta analysis, first, whether it is required or not, the calculation have been made. So as per the calculations, the P delta analysis is not at all required. So that calculation has been made and P delta analysis have not been taken over. So story drifts and wind drifts, everything, it is there within the limit. And the torsional irregularity check has been made. Everything is torsionally regular. And mass participation, as per the codal provisions, it has been well within the limit. Fine, now I will come to some few things which is more interesting. The point number one, it is on the RC. Normally, as EVERSENDAI, we ourselves, we have a thought that when we go with buildings lesser than 20-story building, going with composite is not going to be a good solution. That is what we also had if it is less than 20 stories. Since we have been taking over 60-story, 100-story, 118 recently we have done in KL. So, but the future nowadays coming in, now the composite structures has to be made even with 8 stories, even with 12 stories. The beauty is, majorly it is on the construction material availability and the manpower availability. Also the space in terms of carpet area, we have a huge carpet area which is going to be available, and the construction speed based on the manpower availability. Previously we have been talking about in India we have all the manpower, but nowadays it is not such. So that is the case, and we have done the studies. There are quite a few savings in terms of carpet area we have. So the prototypes, as DLF management, they wanted to have, this is their first composite building for DLF. So after that, they have done 3 buildings. So we have done with the prototypes and explained how their MEP pipes are how to be come. And there are few options have been given why we cannot open that one. But as a developer, they want to give the flexibility for the tenant to go with their own MEP layout, so that they wanted to have all the MEP panels below the structures. Otherwise, it is better to go with the opening in the steel beam itself. So this is the typical structural steel composite layout. So the beauty of this particular connections is you can see the steel beams have been taken out of the composite columns. So that means when I have a formwork, I have to slit only once. I will just, yeah. Sorry. I will just. Yes. Normally in construction industry, so far, what we will be doing is we will take the member inside most of the case, or we will be having some because of these few facilities we will having stuff. So what was happening is because of this stuff, the formwork becomes more difficult. But this has been taken over by means of complete design taken over during construction and after construction. The load has been varied, and this has been taken over. So this is a very simple detail which have been following first time in this project, and we are following in the next few projects also we are following. So this is that one. So this is the project. So with this remarks, I just conclude. I just giving you a few photographs. Fine, if you have any questions, you can ask me. So if not, thank you all. Thank you.